As gravity compressed the clouds, the voids between them grew bigger, and the gas clouds themselves became denser and hotter. The clouds were then drawn together by gravitational filaments like beads on threads of a cosmic web. And where the giant filaments formed large masses, stars and galaxies formed.
As the universe evolved, gases were able to condense into clouds, which collapse to form stars. The stars settle into a rotating disk that was later to become a spiral galaxy like the Milky Way.
Over millions of years, as the hydrogen atoms clumped together and heated up, they began to fuse and release energy, causing the cloud to burn brightly. Eventually, a star was born. All over the universe, millions of stars ignited for the first time.
The appearance of the first stars would have been a truly spectacular event. Had we been there, we would have really seen fireworks. Individual, enormous flashes of light generated as the stars are born and burn.
Atoms came from the British astrophysicist Sir Fred Hoyle, one of the greatest astronomers of the 20th century. Hoyle didn't believe that the universe began in a single explosion. In fact, he coined the name Big Bang as a term of derision. Hoyle wanted to know where the elements heavier than hydrogen and helium had come from. He determined that stars acted like nuclear reactors, working in a similar fashion to a hydrogen bomb, but many billions of times more powerful. And their nuclear waste was new elements. It would be years before scientists were able to confirm his theory by analyzing the light from stars, back through space and time, and examine early stars to discover if they were making new elements. But the dream soon turned into a nightmare. After it was launched, the scientists discovered that Hubble's mirror was distorted, meaning it saw everything out of focus. It needed corrective lenses, and the only way to fix it was to send up another space shuttle. One of the repairmen was astronaut Jeff Hoffman.
We were working with a $2 billion telescope, and the last thing we wanted was to break something and leave it worse off than when we got up there.
The crew of the rescue mission had to capture the crippled telescope. Then they had to perform a repair unprecedented in the history of spaceflight. First, they had to open the access doors on the side of the telescope.
The one thing about working on Hubble that is very different from working on a car is you look over your shoulder and there you are in space. The Earth is going by below you, the stars above you.
The astronauts had to carry out fine, detailed work in the most difficult of conditions.
When you're working in a spacesuit, your hands are encumbered by thick, stiff gloves. It's sort of like working in ski mittens, and it was quite a challenge.
Everything was going well until Hoffman attempted to close the huge access doors.
I just had to close up the doors, and when I went to close them, they wouldn't close properly. The doors were somewhat warped, and it took a while for it to sink in. This was very serious. If you can't get the doors closed, you lose the telescope.
Using improvised tools, Jeff and a colleague were finally able to close the doors. It took the team 5 days to repair the stricken telescope. Cosmologists around the world held their breath and waited to see if the most expensive telescope ever built would deliver what its designers originally promised.
I well remember New Year's Eve, 1993, December 31st, when my phone rang, and it was an old friend who worked at the Space Telescope Science Institute in Baltimore. He said, "Jeff, you have any champagne left over from your party?" I said, "Yeah, we still have a half bottle in the refrigerator." He said, "Well, crack it open again and drink a glass because we got the first picture back and Hubble works."
This is what Hubble saw. The images were beyond anyone's wildest dreams. Hubble captured the final moments of a star's life as it exploded, blowing off gas and dust. It also captured interstellar nurseries of newborn stars exploding into life billions of years ago, and dark pillars of cosmic dust, millions and millions of kilometers long, ready to spawn a new generation of stars and planets. But Hubble's true moment of glory was yet to come. Over a 10-day period in 1995, the mission controllers pointed the telescope at a distant, empty patch of space. What emerged was the deep field image, a tapestry of distant galaxies. Hubble was looking back in time to some of the first galaxies and stars ever created.
It revealed thousands of galaxies that hadn't been seen before, so the universe became, to our consciousness, far richer after the Hubble Deep Field.
It showed for the first time faint images of galaxies formed just 1 billion years after the Big Bang. Scientists then examined the spectrum of light from these distant stars and proved that these early galaxies had already created elements heavier than hydrogen and helium. Sir Fred Hoyle may have been wrong about the birth of the universe, but he was absolutely right about stars. These early stars acted like giant thermonuclear reactors, creating new elements.
You can think of the creation of all the elements in this room as, in some sense, like a car assembly line. Because in a car assembly line, each part is sequentially added to the vehicle until it's complete.
Fusion reactions inside these young stars released enormous amounts of energy and heat, which forced atoms to fuse and form new, heavier elements, one after the other. 3 helium nuclei combined to form carbon, 2 carbon nuclei fused to form magnesium, magnesium formed neon, and so on over a period of hundreds of thousands of years, until silicon finally fused to form iron. Iron is a very special atom. The protons and neutrons inside its nucleus are very tightly bound together, so that even the extreme temperatures inside stars couldn't get it to fuse into heavier elements. Iron was the end of the road. The production line of elements was shut down. But our universe was still not complete. There were all the ingredients to make a glass of water, and some of the elements to... The universe was about to enter a super creative phase, during which it would produce all the elements heavier than iron. Forming these missing pieces would take some of the most powerful explosions the universe has ever seen. Our universe was now 500 million years old. There would be another 13 billion to go before humans would appear on the face of the Earth. Giant new stars had made many of the elements present in the world around us, but some vital elements were still missing. Heavy metals like chromium and zinc, and expensive ones like gold and platinum. To finish the job, the universe conjured up the most amazing phenomena since the Big Bang. Massive exploding stars called supernovas. When the giant stars that made the lighter elements ran out of fuel, they collapsed in on themselves, creating incredible amounts of energy and enormous explosions. These explosions were so powerful that they were able to fuse elements heavier than iron, and so restart the element production line. Tony Metzacapa from Oak Ridge National Laboratory in Tennessee believes that without exploding stars, life itself would not exist.
Life as we know it certainly would not exist were it not for core collapse supernova events. They are very clearly one of the key links in our chain of origin from the Big Bang to the present day.
A large supernova close to our galaxy was seen in the southern hemisphere in 1987. When a supernova like 1987A explodes, it emits light containing the signatures of the elements within it. And by examining the spectrum of this light, scientists can calculate what elements are being forged inside the star's core are torn apart, and the core destabilizes.
The cores then collapse.